what we generate and is also what we want to predict. And we have more than 60 million active customers. And one important thing to know about Zalando is that this huge scale, I believe, that has only worked to grow so fast because we are a data-driven company. So Zalando is using data for every decision making, being small or large, and always put the customer at the top as a goal. Like, how do we make our customer have an amazing experience, and how do we become the leading multi-brand fashion game changer in Europe? And what we do actually in my team, as applied scientists, we forecast the GMV that you just saw in the previous slide, but for each market independently. When I say market, I mean like Germany, Austria, and so on. Closest to Serbia is Croatia, so if someone is interested in trying out the order at Zalando, if you're on holidays there, you can try it out. And we do it on a daily granularity for the next 16 weeks. And what we are interested in when we produce this forecast are three main, let's say, properties of that focus. It should be robust, it should be reliable, and it should be accurate, right? So when we say robust, we mean every Monday the forecast should be there for our teams in the operational business to use it. When we mean reliable, it means that no number we said last week should be similar to what we are saying that we will achieve this week and so on. So they should have a feeling that it's correct. But most of all, it should be actually correct, right? So we should go back and see how accurate we were and always aim for a better accuracy. So how do we achieve this? First of all, here is a bit of technical, let's say, short overview of the model that we are using. Don't worry that you might not read what's written here in the graph. I think what is important are the 4 steps here that are listed, and on the right side is the description of it in a visual form. Basically, we have our historical time series data, and we know that it has some trend because Zalando, as you can imagine, has been growing a lot in the recent years. On the other hand, there were some bumps given the different, let's say, changes in the world, and we different the data, and then we will forecast the trend separately and the reminder separately. Then we use some machine learning model, some of them deep learning models like TFT model from Google, and also some other like Process from Facebook and other machine learning models to forecast this reminder part. And at the end we collect all together and we do some post-processing as a third step, because we know that sometimes the forecast brings some error and is kind of having this error in the last week. We know that we can fix it because it's a recent trend. So we try to fix these recent errors. And finally, I mentioned that we have the forecast for the next 16 weeks, or 112 days. And as you can imagine, it's a different thing, and I'll speak about this at the end, to forecast on a daily level or on a monthly level, or let's say a weekly level or a monthly level. If you ask me to give you the forecast for the next 12 months or the next 2 or 3 months, you can imagine this is a bit easier because it's a larger number. On the other side, if you ask me about daily, forecasting the next 3 days is much easier than forecasting, let's say, 75 days from today. Think about the weather, it's the same, right? We know, or even for today, I guess we didn't have a right forecast, that's why we're sitting in this room instead of downstairs only now, and not from the beginning, let's say, right? So these things are different, and that's why we forecast also differently. So we use one model for the daily level, another model for the weekly level, and then we try to reconcile them because it should all add up correctly, and we give this to our stakeholders, so the planners. We have different teams and departments at Zalando that are using our forecast, commercial planners that are looking at our marketing activities, and also pricing teams who are looking at changing the discount and the coupon rate. Then we have the finance team who is working on the budget, Christmas time when people don't have that much time for shopping most of the time. Or also customer care, so how many people should we have for our customer care, when do we expect more or less calls to customer service, and so on. So all of this information then goes to them and they are free to use it or not use it, right? We will come to that a bit later. Then I want to show you about the scalability of the demand forecasting. As you can imagine, we are speaking here about lots of countries, we are speaking about deep learning models, we are speaking about very large and historical data, and all of this needs to function, let's say, perfectly most of the time, right? We use different services, and if there are some questions about this, we even have one ex-data engineer here from Zalando who worked on, or is also currently working on this field, on how it all works. We have integrated some data quality checks, then we have also integrated our custom machine learning flow based on SageMaker, and we orchestrate everything with Airflow. So it's made nice and easy for us as data scientists to use it, but also for the engineers to have a good understanding and can react fast when something goes wrong, especially in the data preparation part. Because if we don't have ready data, then the forecast cannot be produced. And okay, so we've made these models, we put it to production, everything works well, we know it's very accurate. What I like about working in forecasting is that you can go back and check how accurate was your forecast, and you have a kind of feeling how good is your work. And our goal as applied scientists most of the time is that we have an accurate forecast, so that we have a high accuracy. But when we talk to our stakeholders, we understand that actually there is one thing that is sometimes even more important, and that is stability. And that's why I say here stability is the new accuracy, because what we saw when our stakeholders started to use our forecast very actively is that they stick to this one number. Okay, the forecast for Poland 3 weeks ago, for whatever week now, let's say last week of December, was X million. And now you are telling me completely another number. And I already planned having the initial number in mind. So why this changed? Of course, why? This is an explainable forecast. This is also what we are trying to do. But most importantly, is like, can you please not do this? This is what we've been asked. And then we need to trade off. So we need to give up a little bit of the accuracy, but have a more stable forecast, because that will lead to a stable planning. And this planning is even more important than fighting for this 2% of deviation or 0.5% that we as applied scientists are kind of fighting for. But if people don't need it, if our stakeholders don't need it, then it makes no sense to fight for that. So that's why we focus on stability as well and work on some methods to get there. And then what that leads to is that we could also make a more automated decisions based on this. So we have stakeholders, so planners, who are actually able to adjust the forecast that we produce, but with the time we are able to make our forecast to be the main, let's say, number that will be used more and more. And we call this automated forecasting or automated planning, because at the end, speaking in a kind of like a common language, we can say that the machine is trusted more than the people. And this is amazing, and it also feels us that, okay, it's used, so that's the best, I guess, measure of success, right? Even more than accuracy, it's important that it's actually not created in vain. And now we created this, right? And it's adopted, it's in production, it's used for decision making, everything looks perfect. What do we do? Can we just go home, so to say, because we've also automated the process? No, actually we should not stop here, and especially not because what we've built is a tool. It's a And the interesting thing here is that, as you can imagine, all of these numbers are related to each other. So there is an actual mathematical formula, right? If you bought a certain number of items, each of them cost a certain amount of money. This is your total GMV. So there is a formula that is relating them. And if we, using our product, forecast them independently, this is amazing. We can have a great forecast, very accurate for each of them independently, but we end up with the problem that the formula doesn't hold anymore. And then our stakeholders are unhappy again, because they're like, this can't be. And again, we need to give up on the accuracy, perhaps, perhaps not. So this is still in a testing phase. Let's say we are currently working on this. How do we achieve a good, accurate forecast for each of these things, and at the same time maintaining their natural relationship, right? So this is called consolidation or reconciliation. Most of the time, if you read in the literature about reconciliation in time series forecasting, you will hear about it in a temporal way. So, for example, I spoke about daily, weekly. If you imagine, I'm telling you the GMV that we will generate from Monday to Sunday separately, and if on the other side I tell you this is your weekly forecast, of course these 7 have to match to the one that was said to be the weekly one. If you produce them separately, they will also not match. And there is a lot of work on how to match on this type of granularity and this type of hierarchy, right? So this is actually called hierarchical forecasting. Or what you can imagine if we were, and this is not my work, this is a work of my colleagues, other applied scientists at Zalando, is we were forecasting on an item level, so SKU level, so forecasting how many jeans, how many skirts and socks and shoes we will sell. And then if you have commodity groups like male clothes and female shoes and whatever, they also have to sum up and be correct them in the hierarchy. But we are having here a little bit of a different problem, and still using those methods, we are able to solve this, and hopefully without losing on the accuracy, and actually sometimes even gaining accuracy. So some of the forecasts which are actually very bad, with the help of this reconciliation, can have a better accuracy. So let's see. I think that's it. So I have some time for questions, if there are any. Yes?
Can you please explain, as technical as possible, how does the model work? What are the parameters of input and output? How is it trained?
Yes.
And then used?
Yes, yes. So very good question, because I told you you don't have to look in the small graph here, but actually if you could, then you would be able to read this. It was even there, very good sketch, because I did not cover this. I'm happy to tell about this, right? Because as you can imagine, indeed, using only historical data for the historical demand is not enough. Or it can give us some information, but most of the time this would be the classical, let's say, univariate time series forecasting from statistics from many years ago. Often it's very good, and actually for some markets we need to think, okay, maybe this is good enough, right? But for the markets which are very big and which we have lots of data and lots of historical values, we can also well imagine that adding additional parameters, additional variables to the model will improve accuracy by that. So indeed we use some, we call them covariates or other additional feature, the marketing, right? How do I compare that one to my old model? Because you can imagine that this is a complex question. Maybe I just try on last week's data and it improved, and I'm like, hooray, made improvement in the production. So maybe this was just luck, right? So this is another question, how do you choose? And among this variety of options, not only the parameters of the model, but also a set of covariates to add, how do we then choose which model do we go with? Yes?
So my question is this type of fusion transformer now state of the art in financial forecasting? Maybe how much better it is compared to simple financial splitting when they issue a bunch of different
Yeah, so very good question. I think that PhD is kind of state of the art. We have also tried DeepL, so the AWS solution, also neural network based. For some markets, we got some improvement, but it was a huge effort to introduce yet another model to the system, so we dropped it. But on the other hand, I agree, exponential smoothing is actually very powerful. So every time we try some, as I said, like new covariates or new ideas, we try to have a good baseline, right? And profit, exponential smoothing, especially because they are extremely fast, are always on the table and they are our benchmark. So for new markets, or markets where we have little data, where we don't have that much covariates and where there's no stability, the simpler statistical models sometimes work better. This is true. How much? Yeah, sorry, I can't hear this.
I have two questions actually. One is, do you also consider as a covariate like index such as GDP of the country, like economical indexes of the country?
Yeah, I mean, this was on the table, especially when the inflation started to jump around. We've been trying this because, yeah, I think so taking just one number, let's say for Germany, right, if we forecast Germany on its own, then, yes, I mean, we could still do. So let's say what we tried was the inflation rate, let's say, per market. Another thing that we have tried is the change of currency, because we operate in some markets where not a euro value but another monetary value is used, like Switzerland and Czech Republic and other markets, and there the exchange rate ratio between the currency also plays a big role, and this is also another thing that we have tried with.
And the other question was like, how do you deal with new product? Like, I'm a customer of Zalando, so I know that like the list of items is like infinite. So
Yeah.
how do you deal with products that are starting to sell now at the moment? How do you generalize the model itself?
Yeah, thanks a lot. So, I mean, here, since we are on a market level, we have the total that we generate when you sum up all possible products that we've been selling. So we don't have this, it's called cold start, right, where you have no previous input. But what we do have, and this has been on the table for quite a lot in the last years, is that we have completely new markets. So let's say we introduce Zalando in Croatia, we have zero data, right? So how do we go for there? I have to say at the moment, this is an extremely difficult question, right? So people who are working on the level of items, they also have this question, and also it's a question that also there are some items that are in the assortment, but people like rarely buy them, and then they deal with lots of data, with lots of zeros. I think it's a whole another topic of time series forecasting when you have all this kind of empty data. What do you do with this? Usually we don't have this, and when we have a new market, most of the time in the first at least a year or so, this is done still by a person who knows other markets, can compare and have a feeling and so on, and we leave it
remove that data from the series in the nodes.
Yeah. We don't remove the data, but we try to account for it. I mean, if we notice some outliers, we do remove them, and then we let it, when we speak about neural network, we let the system learn, and to some extent it's possible. But sometimes, like if you now ask me for Black Friday, for example, it's still like a shock event. So Black Friday is a big thing at Zalando, and I think in general, and it's a huge spike. It's extremely difficult to predict this one. And I think this is also one place where machine is a bit lost every time, because it just, we don't actually have once per year, so there is not that much data, right? So we forecast the whole year, we try to adapt, and we are, I think nowadays we are a bit more stable. So about 2 years ago, when the pandemic was just kind of ending, and we had this huge peak, the focus was not that accurate. Yes?
Do you study the impact of stock availability, in-stock availability on demand forecast?
We don't in this particular project, because we are looking at the demand for the whole market at once.
Okay, not by product.
Yeah, exactly. So, but my colleagues that are working on the SKU level and the product level, they do take this into account.
Thanks.
We had the privilege to learn from you for the second time today, so